Welcome to Scaling Up H2O, the podcast where we scale up on knowledge so we don't scale up our systems. Hello, everybody. Trace Blackmore here. I get to host this fantastic podcast called Scaling Up H2O. And folks, I want to tell you that it is fantastic because of the write-ins, the calls, the voicemails, all the things that I get from you, the Scaling Up Nation, letting me know what to talk about and that I am talking about the right things that can help you raise the bar on your day-to-day to make your day-to-day better. So thank you so much for all those people that have let me know about that. And if you have an idea that you want to get to me about who to interview, what to talk about, a question you might have, go to ScalingUpH2O.com, go to our show ideas page, and you can let us know all about it. Of course, if you want to record your voice, there will be a pop-up on the right-hand side of the screen that says record voicemail. You can record your own voice asking your own question to me, and that will allow me to place your voice on the air and answer your question right there on an episode of Scaling Up H2O. So whatever fashion you choose to use, I hope you choose to use it because I love answering questions from you because it means I am talking about the very thing that you want me to talk about. Now, last week, we talked about how to use a calendar properly and how to really properly plan for 2021. We finally got over 2020. I know a lot of us are happy about that, but let's face it, we got through it. We got a lot of experiences and we learned that we can work in pretty much any condition that we were asked to work in. So that's an accomplishment. And I think we can take the trials and tribulations of last year and apply that so we can get even better results this year. So it's my hope that you have your 2021 planned out. A great book that I mentioned last week was a book called The 12-Week Year. It's a great book that allows you to learn some of the principles of planning, but more importantly, it's one of the best books that talks about execution and how to execute when life happens and it doesn't necessarily go according to plan. Well, 12-Week Year helps you with all of that. And it comes straight out and says that if you develop these tactics that you were supposed to do to achieve these goals and you get 85% of these tactics done week to week, you should not have any issue getting your goals accomplished. So I've used 12-Week Year for several years now. It's been a great tool. It's a tool that we're using in the Rising Tide Mastermind. I know you hear me talk about the Rising Tide Mastermind on this show. So pleased to tell you we're up to 4 groups with over 40 members in the Rising Tide Mastermind. We're continuing to add people on our waiting list. So if joining the Rising Tide Mastermind is something that you are thinking of, I urge you to go to ScalingUpH2O.com/mastermind to learn more about the Rising Tide Mastermind. If everything you read there sounds good, we can schedule a call together where you and I can talk about all the ins and outs of being a member of the Rising Tide Mastermind. And if that all sounds good to you, we can get you on that waiting list so you can be one of the next members. If it doesn't sound like it's right for you, I hope now you're thinking about a group like that, and perhaps you can go and find a group that does sound right for you. Because as I mentioned, one of the things we try to do is bring ideas to the group so they can stay laser focused in a particular process and not have to go out and find that process. And the process that we're doing right now is 3-year planning, 12-week year style. So people are going 3 years into the future to figure out what they want to accomplish. They're coming back to present day, and now they're writing the plans for the next quarter that they're going to have to work on in order to complete those goals in a 3-year period. Folks, this is a great exercise. I know a lot of us do 1-year planning, and 1-year planning is phenomenal because we can get very strategic in 1-year time blocks. The neat thing about going out 3 years is we still have the ability to do that strategic 1-year plan, But by going 3 years out, we give ourselves permission to dream. What can I really accomplish if I stretch myself? If I use other people's help, what can I do in 3 years? And when you are able to get in that mindset and figure out all these things that you really want to accomplish, and you got 3 years to do them, and now you can come back to present day and figure out what you need to start working on. And you've got people that will help hold you accountable to get those things done and even help pick you back up when you start to struggle. That is where the power lies within a group like this. So I hope you guys check it out. I hope you guys join a group. I hope you all do 3-year planning. It is a fun exercise. And I'm really looking forward to what 2021 has to bring. I'm looking forward to you meeting your endeavors, your goals, your future accomplishments. And I know something that 2020 didn't allow us to do very much of was network. So what AWT, the Association of Water Technologies, and the Scaling Up H2O podcast have been doing is bringing you a regular hang where we can get together with like-minded individuals. We can meet new people. We can tell them a little bit about ourselves. And maybe the other person we're talking to is somebody that can help us with a current or future issues. Well, we're continuing that this January. In fact, it's going to be on the 14th this month, and that's just right around the corner. So if you have not registered for the next AWT Scaling Up H2O hang, please go to scalinguph2o.com/hang to register, and we will put you on a Zoom call promptly at 6 p.m. on the 14th of January. We'll have a couple of announcements, and then I'll quickly get you into a breakout room where you'll meet probably about 5 people in 2 separate breakout rooms. Folks, trust me, this is a great and easy way for you to meet new people within the industry without having to travel, without having to do a lot of heavy lifting. So I urge you, if you've been on these hangs before, please continue to join the hangs and tell somebody about how awesome that these hangs are. If you are considering joining the hang, I would say do it. Block out exactly 1 hour. I won't go long. So 6 p.m., January 14th, scalinguph2o.com/hang. Speaking of the Association of Water Technologies, something that the AWT and the Scaling Up H2O podcast are doing together is the business webinar series. And a lot of you attend the business owner meeting that takes place every first quarter that the AWT puts on. I know it's one of the things that I look forward to, but unfortunately, with all the things that are going on this year, with all the uncertainty, we just didn't know if, one, we were going to be allowed to meet, what the venue was going to be like, all of those things. So the AWT is going to do their business owners meeting the first day before the AWT convention. So please, if you're planning on going to the AWT convention, and why wouldn't you, plan to go a day or so before so you can go to this business owners meeting. I always get a lot of great information out of that, and I can't wait to go when we are at the convention. But I know a lot of you, like me, want to get information before then. So AWT and the Scaling Up H2O podcast have gotten together, and we are putting on the business webinar series. And what we're going to do is every couple of months, we're going to put on a different speaker where we're going to be on a Zoom call. You're going to get to know information that the speaker is trying to convey. And then afterwards, we're going to go into a small breakout session where you can work on something. And then we'll come back into a main room, and the speaker will give you actual handles, things that you can do in your business today from what you've learned. Now, the first one we're going to have is January 29th, and that is going to be with CEO Sensei John Fenton. So John was on a previous episode of Scaling Up H2O. He's turned into a really good friend of mine, and he is just fantastic with talking about all the things that the business owner needs to think about in order to be healthy, in order to run a complete healthy business. And you think about that's yourself, that's your employees, that is your customers, that is your processes, that's your procedures, that's your finances, that's everything. So, what John does is he makes sure that you stayed center on the things that you need to be focusing on. And also, let's face it, we've got to surround ourselves with certain people that can help us see certain blind spots so we can work on the proper items. Trust me, you are not going to want to miss John Fenton in this business webinar series. So that's going to be January 29th at 11 a.m. Eastern time. Go ahead and block off 2 hours. You can eat your lunch during that time. Nobody will say anything if you do that. And what we're going to do is we're going to have where John is going to tell us some information that we need to know. And then we're going to move into breakout sessions where you're going to work with some other people on the webinar. John will go in and out of the breakout rooms to help you with anything that you're stuck on. And then after that's concluded, we're going to come back into a main room. John is going to wrap things up for us and give us some very defined handles that we can take from this session and immediately start working on. So I hope you go to scalinguph2o.com/business, and you can find out everything you need to know about that, even register for that. As we talked about on the very first episode of this year, make sure you get that on your calendar so you can plan for it. And then we're going to do future webinar series. There's going to be one March 26th, one May 28th, and one October 29th. So we've got so many speakers planned for you to learn more about the things that you need to know, but more importantly, to give you some actual tools that you can start using right during that day. So again, go to scalinguph2o.com/business and you can learn all about that. I hope to see you there. And I want to get on to my guest because my guest is also a very good friend of mine. You've heard him before. Of course, this is Mike Standish of Radical Polymers. Mike and I met each other on the Association of Water Technologies Board of Directors. We both came on the board, I don't even know how many years ago it was, but we didn't know anything about being on the AWT board. We kind of learned those ropes together, and we have been great friends ever since. I've heard so many good things about the first time Mike came on. He was one of my first guests when I started the podcast about how Mike really broke down how simple polymers could be. And of course, that's not a simple topic at all, but he broke it down very easily for us, allowing us to navigate through that windy road that we call polymers. Well, as what we've come to expect with Radical Polymers and Mike Standish, they're always trying to push the envelope. So we're going to learn from Mike what they are doing this year. So please welcome Mike Standish of Radical Polymers. Scaling Up Nation, my returning lab partner today is none other than Mike Standish of Radical Polymers. How are you, Mike?
I'm doing well. Happy to be here with you today, Trace.
Well, we had a blast. You were one of my very first guests when I started this podcast. And you did a heck of a job of taking probably one of the most complex topics that we have in our water treatment wares, which is polymers. And you gave us a very simplistic way to make sense out of all of them. So you've got some pretty high bars to fill on today's episode.
That's not necessarily good news, but that's okay.
No, seriously, I got so much feedback about how you took something that was so complex and gave people really easy ways to comprehend something that is almost impossible if you're not a chemist to understand.
Yeah, I mean, I think I've been fortunate and blessed throughout my career that I've been around a lot of people that have understood polymer technology in a lot deeper detail than I do personally. But as more of an applications chemist, it's been kind of my job and helpful to me to essentially translate the complexities into, practical use. And so that, I've kind of carried that with me throughout my career is hopefully being able to take, like you said, something that's pretty complex and boil that down to the essentials.
Well, the last time you were on was September 1st of 2017. So Nation, if you have not listened to that episode, that was one of the very early ones. It was episode 14. Definitely worth a listen and probably even a re-listen. So last time the ScaleUp Nation heard from you, Mike, was again September 1st, 2017. What have you been up to since then?
Well, as a company, we've really been building up our capabilities. Since that time, we've installed some really best-in-class pilot testing equipment for cooling water, and we've been awarded very proudly the AWT Supplier of the Year in 2018. And most recently, we've invested in a really first-class piece of equipment for X-ray fluorescence with the purpose of really reaching out to our customers and helping support them with problem solving around deposit analysis.
Well, Mike, you and I aren't far from each other. I'm in Atlanta. You're in Chattanooga. That's just a couple hours away. And you've been inviting me up to see all this equipment. And I haven't seen it firsthand, but you've sent me pictures. And I want you to go into what you've actually set up there in order to be able to test, because I don't think we're going to be able to do it justice over a podcast format, but it is just incredible what you are able to do up there.
Yeah, I mean, I think, for us, the way I look at things for our customer base and prospects, when they're evaluating a water treatment additive to put in their own formulations, they need to have data that's supportive of how the product functions versus competitive materials, or how the product functions in an application that they're going into. So our business is very driven around that concept of that we're going to develop meaningful information about our products that show where they work and where they don't work. And so we do that kind of in layers. We have laboratory capabilities to do benchtop testing, which is kind of the basics of looking at, one functionality versus another. But where we've made the biggest investment is in pilot testing. So, it approaches, it's not an exact, replica of what's happening in the field, but it starts to give us, data around our products that are in simulated cooling water applications. So much more in alignment with, the actual field end use of formulations and additives.
Mike, take us through the process, because I'm sure there are listeners out there that they just receive the products. They've already been blended. They don't understand the journey that has to be taken through in order for a product to go from concept into it actually going onto one of our accounts. So we now have this idea. We want to create this product. How does it go from an idea to at the customer?
Yeah, so I've been doing this for 34 years in a lot of different contexts, with big companies, and then now with our own small company. And the process, that's a very good question, Trace, because the process is pretty consistent regardless. Typically in our case with synthetic polymers, the origination of what's happening is exactly what you said. There's some idea that, look, we want to create product X, or we want to create a product that has certain functionality. And probably the most cumbersome part of that process, or the most time exhausting and resource exhausting part of that process, is the exchange between the synthesis chemist and the applications chemist, because you start off by evaluating typically a very large number of prototypes. And then you start to, in our case, a lot of the research is kind of more Edisonian, in that, you'll make one polymer composition and you'll see that it has certain properties, and then you take learnings from that and you make a modification of that, and so on, until you refine to a point that you think that you have something that's worth commercializing. And then when you get to that point, then it kind of is thrown totally over into the application side where you generate as much kind of what if information as you can. How stable is it in the presence of oxidizing biocides, or how does it work, when we see a pH spike in the application, or how does it work in high hardness waters or low hardness waters with high corrosivity. So you start on the application side to really try to map that out and generate as much information as possible, because at least from my perspective, what should be the value proposition of any additive to the customer, the formulator or the end user of the material, is really understanding kind of the limits of its efficacy on one hand, but also where the product should not be applied as well. So, yeah, I think, the overall process is one that is an exchange between synthesis team and applications team. And then once the product is refined, then the applications team takes over and really looks at a lot of data to try to understand where the product functions and where it shouldn't be applied.
So when it gets out into the field, what does field testing look like?
Typically, that's certainly in our case, where we're mainly working with independent companies. Our case is largely where we would have some sort of collaboration with one or more companies to test out in the field and confirm out in the field what we've seen in the laboratory and in the pilot systems. And typically, we would, and a lot of vendors would work very closely with their customer base to make this transition. And sometimes, you can find information out from that is either surprisingly good, or sometimes you might find something that says, okay, we need to go back to the drawing board.
How often does the benchmarking data that you collect in a controlled area, such as your testing center, almost always match what you get in the field?
I think that's a little hard to answer, but more times than not, I would say that it does. But that's not smoke and mirrors or sleight of hand. It's really because of a couple of things. One is the technology that's being practiced in water treatment additives is largely kind of between two ditches. So people use essentially the same type of building blocks. They just start to modify, what those building blocks look like and what ratios they may go together in and what have you. So, it's rare, at least in the areas that I'm involved in, that we stray, way outside with kind of crazy technology that doesn't have some sort of basis of, field use already. So it tends to be variations on a theme to a large degree. So the chances of just catastrophic failure are pretty low for most additives that are introduced into the water market that I'm aware of. I think the other component of that too is that there are a lot of people in this industry on the additives development side that have a lot of experience and kind of been through those trials and tribulations where they've had failures and had successes. And so, I think the community in general has a pretty good working knowledge of what functionality works and what functionality, is more speculative.
One of the things, there's so many things that I love about our industry, but we never seem to be happy with how things are. We always want to make improvements. And that's something that you've done a lot in the water treatment industry was improving on how we use polymers, how we understand polymers. And now you are doing something with how we even test for polymers. So can you tell us a little bit about what you're doing now?
Yeah. So one of the things that we've done most recently is, of course, this industry is very, very familiar with the use of PTSA, fluorescein, and other fluorescent inert materials that are added to formulations to track formulation dosage in a system. Over quite a bit of time, there's been a lot of attempts to also add fluorescent components or other tags to polymers and other water treatment additives, but largely those have been unsuccessful over time. There's been things like immunoassay methodologies, kind of like pregnancy type tests that have been attempted. There's some turbidity tests that are attempted. They all kind of have pros and cons. And what we've been working on over the last couple of years is a way to take a fluorescent monomer or a monomer that has fluorescent capabilities and then covalently bind that to the polymer, where the polymer itself is tagged and measurable and distinctly measurable from other things like PTSA or fluorescein.
We've been using products like this for years where we have a product, it's working well. We put PTSA in it, and now we're able to measure the amount of product that has gone into the system. How is what you're talking about different from that?
Yeah, so I think what your listeners have to understand is that a material like PTSA is an inert tracer. So it's really a proxy for what's going on in the system and how much of your formulation or chemical is in a system. But think about it this way, the fate of PTSA, say in a cooling water system, doesn't necessarily reflect the fate of the polymer, the phosphonate, the azole, your mild steel corrosion inhibitor, what have you. Really what the PTSA inert tracer allows you to understand is, okay, I intended to add 100 ppm of my formula into the application, and I'm measuring, by ratio 100 ppb of PTSA. Okay, I've added the correct amount. It really gives you no indication of that formula that I've added to the system that has functionality for scale control, mild steel corrosion control, yellow metal corrosion control. The level of PTSA doesn't necessarily tell you that all those functionalities still exist in the application.
So this is actually allowing us to test to see how much polymer is in the system.
It does. And why that is important, and one of the things as people see the data for these types of materials, one of the things that you'll notice just instantaneously is in testing where you cause an upset or you see precipitation, the polymer tends to follow the precipitation. So is effectively removed as precipitation of something like calcium carbonate or calcium phosphate occurs. So that's very, very important because PTSA does not do that. So the implication is when you see loss of polymer, it's an indication that there's been some upset in the system, but it's also an indication that you don't have enough treatment chemical necessarily to continue to control scaling and corrosion in the application.
So those of us that have used PTSA, we're putting a certain amount of parts per million of our product into the system. We are going to equate that with so many parts per billion of PTSA, but now it's tagged on the polymer. So I'm assuming that we're getting rid of the extra PTSA that was in our product, and we're just using the tag polymer. So two questions with that. That was one question. The second question is, what happens when the polymer is used up to that PTSA?
Trace, there's two competing technologies that are being introduced. One is a polymer that would do exactly what you're speaking about, is you would eliminate the PTSA inert tracer, and you would use only the tagged polymer to trace both your formulation dosage, and you would look for upsets, by increases or decreases in the measurement of the tagged polymer. Our technology is different. So what we would recommend is that people always use the PTSA as an inert tracer, because that tells you how much of your formulation has been added. So if you added what's been intended to be added. And then you would use the polymer, the tagged fluorescent polymer, separately, because it is distinctly measured, or at least our technology is distinctly measured at different wavelengths than the PTSA. So you're tracking both. You're tracking the fluorescence of the PTSA to say, okay, I'm feeding the right amount of my overall formulation. And then you're secondly tracking the polymer by fluorescence and saying, okay, everything's working as it should, or, I'm seeing some change that in the amount of polymer that I'm measuring. So I need to investigate what might be happening in the system and look for upset conditions.
Do you need a special meter to be able to test for both?
You do, and there's been one introduced very recently by Pixis, and I'm sure other companies will also introduce those over time, as this expands. But yes, you do need a special meter to measure, just like you do with the PTSA, to measure the polymer because it's at a separate wavelength that's unique versus PTSA.
Is there anything that happens to the efficacy of the polymer by tagging it with this tracer?
No, nothing that's significant. The tracer, the fluorescent tag that goes onto the polymer goes on at very, very low levels. So it doesn't affect the overall functionality of the polymer for dispersion, scale control, those types of things.
Mike, what happens to the tracing agent once the polymer is used up?
So I think the way to look at it is that the tracing agent or the fluorescent tag is a part of the polymer. So it absolutely is covalently bound to the polymer itself. So you just have to look at it as it's a part of the polymer. So it goes where the polymer goes. So if everything's working great in the application and you're measuring the intended amount of polymer in there, then the tracer along with the polymer itself stay in the circulating water. If you see decreases in polymer concentration via the tracer, then that's an indication of an upset condition. But the tracer is covalently bound and it goes where the polymer is, and in fact is absolutely a component and part of the permanent part of the polymer.
Mike, I have to tell you, this just sounds incredible. I don't know if anybody out there has done a polymer curve or tried to test for polymer, but this just seems like such an easier way. And speaking of that, there are probably some people out there that haven't gone through that procedure. Mike, I know that's what you do. Can you explain how basically that we do traditionally test for polymers so people can see how this is really a tremendous tool that we can now use?
Yeah, so the traditional way to test for polymers and probably the mass way to test for polymers at this point is with turbidity. And the concept there is it's a turbidity type test. And the concept is that your scale control polymers are all anionic in nature. And so you'll take a sample of your water that contains a scale control polymer that's anionic, and then you'll add a cationic polymer to that as a reagent. And that cationic polymer reacts with the anionic scale inhibitor and it forms turbidity that's proportional to the concentration of the anionic polymer that's in there. So you develop a turbidity and you can develop a curve at different concentrations of polymer. And so the increasing level of polymer, you see increasing turbidity. It's a little cumbersome, but it works fairly well in the field as long as you're dealing with relatively clean water. As you might imagine, as you approach applications where you have baseline turbidity from the water itself, then it makes it more and more difficult to develop an effective calibration curve for the polymer using a turbidity method.
And before now, that was the only method that we had of measuring polymer. But now it seems like what you're telling us is we can just simply hit a button and see what's in there.
Yeah, there's also immunoassay methods that are still used to some degree, but you're exactly right. Those also require kind of multiple hands-on type procedures to try. And with the tag polymer, you would measure it just like you do PTSA. You put a small amount of the water in the fluorimeter and you get a reading. And the same is true for the fluorescent tagged polymers.
A lot of us are feeding polymers or actually our products off of PTSA. The controller knows how much to look for. It'll turn on a feed pump and it will pump until that PTSA level is satisfied. Can we do the same thing with the tag polymer approach?
Well, with the technology that we've developed, what we would suggest is you continue to do that. You feed your product based on your PTSA levels that you have set in the system, and then you monitor polymer. And if you see a divergence or a delta between the PTSA and the polymer, that's an indication of an upset condition. That's an indication something else is happening. Because if your PTSA is where you think it should be based on, the set point that you've put in the system, and your polymer is where you think it should be, then everything's going fine. If you see PTSA continue to be where it's anticipated or where it should be, and you start to see a drop in polymer, that's a great indicator or kind of a call to action that something else could be going on in the system, like precipitation of mineral scale.
Mike, you said there was a handheld meter that has the technology to handle both the PTSA reading and the tag polymer reading. Is there a probe for a controller that can do that as well right now?
There is. And I personally don't have expertise on the controller side of our business, but there absolutely is. There's a probe that'll measure both the PTSA and fluorescent polymer. That's an inline probe, and it does connect with major equipment manufacturers' controllers, so you can do exactly what we're talking about: measure PTSA and control based on PTSA, and measure polymer and look for alarms or upsets that are kind of a call to action for investigation.
Yeah, I'm just thinking of what a tremendous tool that would be if you're trying to figure out what's going on. With the controller technology, you can download, you can create graphs to see what's going on. And when you graph both of those, that just paints a picture we've never had before.
No, that you're exactly right. You're exactly right. And I think it's empowering, to the field service team for sure, because the way I tend to look at this is it's almost like kind of a smoke alarm in a way. So measuring the tag polymer, when you see something that's concerning, let's just take an example that you say, okay, I want 10 ppm active polymer in my system at all times. And it's measuring that for, days, weeks, months, years, what have you. Well, all of a sudden one day you see that it's at 5 ppm or less or what have you. It's a call to action, but it's very kind of empowering because you can see that without having to necessarily go out and take a bunch of measurements. So it allows you to do an investigation very similar, to your smoke alarm in your house. If it goes off, you don't, just start screaming and run out of the house. You tend to say, well, where is the smoke? What's happening? And I think, this is a additional tool with the tag polymer that allows you to have a warning of when you need to do that type of investigation.
We started off our conversation by talking about the journey that a product comes from an idea to ultimately arriving on a customer location. So I'm sure we've intrigued a lot of people on using tagged polymers in their existing formulations. So is that just a one-to-one replacement? What do people need to look at if they're considering changing some of their formulations to this tagged polymer technology? What do they need to know? What do they need to do?
I think that they need to work very closely with their vendor for the tagged polymer because each material is going to be somewhat unique. And so, for instance, the first material that our company is introducing is a carboxylate sulfonate copolymer that's tagged. So that's mainly going to have functionality for things like calcium phosphate, iron stabilization, zinc stabilization, so forth. So it'd be very important to work collaboratively with the vendor of the tag polymer to make sure that you understand kind of the limits of where a particular material should be applied. But in saying that, what I would say is that the tag itself does not really impact the functionality of the polymer to any great degree. So, if you're using a carboxylate sulfonate copolymer in a particular application and now you change that to a tag version, it should be a very seamless transition with no technical hiccups with regard to the overall base functionality of the polymer as a scale inhibitor.
So after it's blended, now it goes out into the field and we've got to train our field force on how to use that. Are there any changes if we're talking about an existing formulation and all we did was replace it with this tag polymer for the old polymer that we were using? All the different parameters, alkalinity, silica, phosphate, pH, do those all remain the same? And now all we have to do is add this additional test?
That's correct. As long as you're substituting like functionality for like functionality. So, so we can be clear in that regard, if you're using a, acrylic sulfonate copolymer for calcium phosphate stabilization, and now you substitute with a tag version of that, nothing else changes. You just have additional information that you're gathering. But where I would throw some caution to that is your question would be is look, there's a tag version of the carboxylate sulfonate, but there's not a tag version of a material for high LSI waters or something. You wouldn't want to just make that substitution without kind of assessing the functionality difference between the polymer.
Mike, as a water treater, we're always looking for ways to speed up our process so we can spend less time analyzing, more time doing, so we can get on to our next customer. Because let's face it, there's only so many hours in the day. By replacing our existing polymer with a tagged polymer, does that now allow us to eliminate some of the tests that we run on a normal system?
I would say yes and no. Yes, I think in a way it allows you to at least simplify the testing that you're doing for ongoing monitoring, like we were talking about with the turbidity type test, which is more cumbersome versus just getting a direct reading from a fluorometer, which is very straightforward. However, I would very strongly emphasize that this is a tool. So the ability to measure the polymer via the fluorescent tag is a tool. It's a great tool, but it is not a substitute for water treatment expertise. So I think, what you really need to continue to do is monitor things like delta phosphate, monitor things like turbidity, mass balances on hardness, mass balances on cycles. Those are the pieces of information that give you the data to know whether or not you're effectively treating your system. I view that the tag polymers, what they allow you to do is kind of have this alarm, or the potential of getting some information that is a red flag that you then go and investigate further with all your traditional testing and servicing that a good water treater would do.
Mike, how stable is the tag polymer with halogens?
I can speak for our material. It looks to be quite robust. And I will throw in, as is PTSA. We've done pilot studies with both our product and PTSA where we've maintained between a half and 1 part per million of free residual halogen over a fairly long period of time, like 14 days or so. And we see very, very good stability of the polymer and the PTSA with respect to halogen.
Do we have to worry about using any particular biocides with the product?
Yes, to a degree. So one of the things that we've seen in our pilot testing is we've done some studies where we looked at cationic biocides and how it affects, because it's well known that a cationic biocide really does a number on the level of PTSA in a system. And in fact, we see that dramatically. So for instance, we ran some pilot work where we added cationic biocide at labeled dose levels, and our 100 ppb of PTSA went down to about 30 or mid 30s. And our polymer went from maybe 8 to 10 ppm down to maybe 6 to 7 ppm. So it did have some effect on the polymer. So I think, the users of these products need to be aware that, cationic polymers definitely have a profound impact upon PTSA and can have at least a nominal impact upon the polymer.
Mike, give us an example of a cationic biocide.
Yeah, quaternary ammonium compounds are the most common, that are used out there, and they're phenomenal products that are used in combination with oxidizing biocides many times. But non-ionic quaternary ammonium compounds would be, the most common.
Mike, I know there's so many people that have piqued their interest about this tagged polymer that you're talking about today. If they want to find out more, what should they do?
For our material, they can contact us at Radical Polymers, either through radicalpolymers.com. There's some papers that have been given at the Association of Water Technologies conferences in this past year or 2020. And I personally am more than happy to speak with people about it, and they can reach out to me at mike.standish at radicalpolymers.com.
Well, Mike, if it's okay with you, I'll put those papers right on my show notes page, make it very easy for people to find, and they can look for more information there on the show notes page and then contact you from there.
Absolutely. That'd be great.
Well, I got to ask, I mean, this is tremendous. What are some new technologies that we should be looking out for in the industry?
That's a great question, Trace. As a chemical guy, I'll give you a surprising answer, which, I think a lot of the innovation over the last decade or so in our business has largely been on the equipment side of things, which is spectacular. I mean, our ability to, measure remotely and gather data for systems has really increased in orders of magnitude, versus not that long ago. So I think you should expect to see continued innovation in monitoring and control and equipment. On the chemical side of things, I think there's a lot of work going on in zero phosphorus formulations and zero phosphorus chemicals for mild steel corrosion control. So I think, you'll continue to see people innovate in that area. Quite a number of companies are working on those types of technologies. And then, I think you'll see that the fluorescent tags will grow in number and nature, and that technology will improve over time as well.
Well, Mike, thanks again for introducing this new technology to the Scaling Up Nation. I know I'm very interested in what you had to say, and I know a lot of other people are. I'm not quite done with our conversation yet. Last time you were on, it was very early in the life of the podcast. I can't remember or not if I asked you the lightning round questions. So just in case I did, we'll see if your answers changed from episode 14. So are you ready for the lightning round?
I am. This feels dangerous to me. But yeah.
The point values are doubles, so we'll see what happens. All right. So if you could go back in time and talk to your former self on your first day as a water additive expert, what advice would you give yourself?
Yeah, I would listen. I would listen a lot more carefully than possibly I have over my 34 years. I've been given a gift in that I was very fortunate to be able to spend a lot of time with people like Art Friedman, Tom Orange, Paul Pecorius, Rob Ferguson, Jasbir Gill. Continue to spend a lot of time with those guys that are truly subject matter experts in this, above and beyond, anybody in the market. And so I think I would really spend more time listening to these guys very intently, because if I had, I would know and understand a lot more than I do today.
Yeah, I'm going to geek myself out here, but I'm a big Star Trek fan, and when Vulcans die, they can just suck all that knowledge out of a person. Wouldn't that be awesome?
Do a mind meld.
Exactly. So now you've outed yourself as a Trek nerd as well.
Yeah, a little bit.
Mike, what are the last few books that you've read?
Well, and this is a little geeky, but I am reading a couple of books right now by Isaac Asimov. But the interesting thing is that he actually has two books that are on the periodic table, and they're pretty interesting. They're very basic, but it kind of talks about how elements were discovered over time, and those are quite interesting to me.
When they make a movie about your life, who plays you?
Well, I would love to be able to give the standard answer of Brad Pitt, but probably more realistically, it's going to be somebody like Brian Dennehy or Chris Farley.
Okay, now I remember. I have asked you these questions because that was the answer that you gave me back in 2017. So we'll have to listen to see how your answers have changed over time. So now my final question If you can go back in time, talk with anybody you wanted to throughout all of history, who would it be with and why?
Well, it would for me. It would probably, if I'm totally honest, it would probably be either a political or biblical figure. But I think on the lighter side of things, maybe somebody like Walt Disney. It's pretty fascinating and intriguing that this guy's created something with a enduring commercial value and interest out in the marketplace. I mean, it's pretty impressive that things that he developed decades and decades and decades ago are still just amazingly popular. So maybe somebody like that. I don't know. There's a lot of people out there, but I like Disney, and that could be a good one.
I think that is a good one. I thought of one more question, and it was based on all of the people that you said poured into you to help you with the knowledge that you now have. And there's so many water treaters out there, and they may not have a mentor yet, and they want to get better in their field. And there's no better way to do that than to get in touch with somebody and to have a relationship with somebody that's already been there. What advice do you have for that person that's thinking about reaching out to somebody?
Absolutely do it. I mean, one of the things that I found, I mentioned earlier, this is my 34th year, and I started out actually working and have continued through my career working mainly with independent water treatment companies. And what you'll find in that area is that everybody wants to help. I mean, it is very, very rare that you would approach someone with a question or a problem or just to seek some training or knowledge that they wouldn't pour out to you. So I think my advice to someone that's looking for that is absolutely ask. Don't be afraid to ask, and just show your gratitude by listening intently and asking more questions.
Well, Mike, I want to show my gratitude by how I listened intently today. And thank you so much for sharing this information. And thanks again for coming on Scaling Up H2O.
Absolutely. It was a pleasure, and thank you for the invitation.
Mike, thanks again for coming on Scaling Up H2O and sharing some of the things that you are working on at Radical Polymers. Now, I'm going to take this product and another product, and I'm going to work that into a presentation that I am going to do for the Association of Water Technologies this year. And what I want to do is I'm going to show you how I took our base formula and we just replaced the polymer with this polymer and another polymer that I am working with. And we're going to show you the results. We're going to show you the testability. We're going to show you everything that we've learned over the next couple of months in doing some field trials. So I hope to present that with you at the next AWT conference. And I'm really excited about both of these products. I know we use PTSA to measure how much product is in the system, but if we can elevate that to figure out how much active products are in the system, that's just going to make our life a lot easier. Folks, I've really enjoyed bringing this episode to you today. Of course, I'm looking forward to bringing you the business webinar series, and I'm also looking forward to bringing you the next AWT hang. If you have not registered for either of those, you can go to scalinguph2o.com/hang to register for the hang that we're going to have at 6 p.m. Eastern Time on January 14th. And if you have not registered for the business webinar series, we're going to do that on January 26th at 11 a.m. Eastern Time with John Fenton. Now, Nation, before we go, we started something new last week with James McDonald, super fan of the show, super supporter. And James is now challenging the Scaling Up Nation each and every week. And last week, he asked us to come up with our elevator speech. And folks, this is a great sales issue. I know when I've taken sales classes, they always have you come up with the elevator speech. And something that I learned, and I can't remember which class I took this from, but they said, your elevator speech needs to be, and the reason they call it an elevator speech, because it shouldn't be any longer than the time it takes to go from one floor to the next floor. And it has to convey to the person that you can solve an issue that they are having. And you know you have a good elevator speech if the person asks you to tell me more. So I hope you've come up with a good elevator speech. I hope that your elevator speech just passed the test that I just gave you. But that was the first challenge that James gave us. So let's listen as James gives us challenge number 2.
Hello, Scaling Up Nation. James McDonald here for your next challenge, James's Challenge. Remember, each week on Scaling Up H2O during the year 2021, you will hear my challenge of the week. There will be a variety of challenges from large to small, but the goal is that by the end of the year, you will be a better industrial water treatment professional, drop by drop. James's challenge of the week is test your makeup water for phosphate. You may be surprised by what you find. Municipalities frequently add phosphate-based products for corrosion, scale, and staining control. Unknown sources of phosphate can certainly throw a boiler or cooling tower program out of control. Start with the orthophosphate test. If polyphosphates are used, you may need to run a digestion procedure or have your lab do it. Lastly, calling your municipality to ask if they use phosphate-based products in their water may actually be the first place to start. Please consider sharing your experience on LinkedIn, tagging it with hashtag JC21 and hashtag ScalingUpH2O. I look forward to hearing about what you discovered.
James, thanks again for the challenge. Folks, I can't wait to see what you're posting that you're doing on social media. I'd love for you to let us know as a nation how you're working on these things, and we can even do some networking through social media, learning how we are rising to the occasion of James's challenge. Folks, I can't wait to bring you another brand new episode next week of Scaling Up H2O. In the meantime, stay safe, and I will talk with you next week.